Hi Java students. Today we're going to learn about the framework that we will be using for our game. So as you know, and as I explained when I first introduced the idea of grids, we eventually want to work to be able to make these kinds of cool looking grid games. In order to do that, you would need the grid, the 2D array itself, and all of that logic, as well as graphics to make this appear beautifully on the screen. Now, to make the grid appear and to see all of the pieces in this way takes a lot of work. So we're going to use a framework to help us with the part that displays the grid on the screen, so that way we can focus on the logic of 2D arrays, but still see it in a really cool kind of graphical way. So in order to be able to use that framework, we're going to make sense of it today. So you should have a notes document called Getting Used to the Framework or Getting Familiar with the Framework. That is what we will be filling in right now. So this is not yet on your notes. This is just listen up for a second so I can explain an idea. In general, there is this type of structure that exists for all high-level programs. Now, this is a topic that I learned a lot about in college, and it comes up for pretty much any other high-level programming when you have these kind of big programs that you are going to make, usually for games, but it exists outside of the game land as well. Things like websites even use this idea, so this is kind of common across a lot of programming. There are three key components to any high-level program. There is a model, there is a view, and there is a controller. And these three ideas interact with each other in a really particular way. So the model is going to hold all of the information about the game, or kind of the information about whatever it is that you are making. So for us, in our situation, the model is going to hold the size of the board, what values are on the board, whose player turn it is, who is winning. All of the logic of the game is going to exist inside of the model. We could have multiple models with different information going on, but for us right now, we're going to have a model to hold all the information for a single game that we're playing. From there, there's also the view. This will be the place where you can edit the way that the screen looks. What colors are we using? How the board displays? Do we have any images? Those kinds of things will be taken care of by the view. And then the controller would be the part that controls the game. So the code of like, what should I do when the user clicks or when the user types? What actually logically should happen as the user interacts, which is slightly different than what happens in the model. The controller is going to go look to the model and say, hey, the user clicked here or typed this. Model, what should I do as far as the game logic is concerned? The game will then tell it what to do, and then the controller says, okay, great, now that I know what the game board looks like, hey, view, how should I make this display? What should it look like? So these three are connected in this way. The controller is kind of the main one, and the controller is kind of looking to the model to get information and then looking to the view of how to display it, but the controller is the main one that's doing all of those things. So in our framework that we are going to be looking at, there are a lot of classes. There's a lot over here. This is what the file will look like when you get the whole framework. There's a lot in here though. There's these, come on. There's all of those classes going on. So what is it that is a class? Well, a class in its most basic form is just a file, right? So we have lots and lots of files going on in this framework. We use these classes most often when we were making our objects. That's the first time that I finally said like, hey, let's add in these different classes all in one project. So thinking back to that ball class from graphics, when we had that ball object that bounced around the screen so that we could have the ball objects galore with the multicolored DVD kind of loading symbol. And it's a way to like have template of some idea. Remember, so an object itself, like the ball, held the variables of the position and speed of the ball, and then to make the ball bounce, the methods of the ball as well. So some of the classes that are in this framework are really, really, really high-level complex objects, like our ball object was an object. And we're going to leave it at that level for now. We will dive into the ones that we care about more and figure out exactly what's going on with those. So the three most important classes to us will be the display, the game board, and the run graphical game. So these are the first three bullets that you should actually see on your notes document. There is a run text game. We are basically never going to use that one. We have this as An option for a debugger, something that we can use if you didn't want things to display graphically. It'll just print out in the console of IntelliJ. It's a much lower level, I think, as far as the fanciness of it. So that one's there as an option if you want a no graphics version. It was really there for remote learning when we weren't sure that every student had graphics at home. But it's there in case we want to use it. We're not going to use it all that much. And I will talk a little bit more later about what that location class is, because those are the two that aren't the three main. I'll talk about those later when and if they matter. But the three that we care about are display, game board, and run graphical game. All right, so let's dive into it. What are each of those? So display is going to be our view. Display shows me, or display is going to control how the game is going to look. So it has all the commands related to the way that the grid is going to look, how the grid gets displayed, literally drawing the lines onto that graphic screen. But it doesn't know anything about what's in the grid or what the values are or anything like that. Its most important command is one where we say, hey, draw the grid, and we pass in the actual 2D array that we want it to draw, and it takes in that information and draws the grid in the way that we want it to. Next, we have game board. Game board is going to be the place that has all of the variables and commands for the game itself. This is where the game logic is going to go. This would be considered our model if we think about that model view controller. This is our model. All the logic of the game exists here. It has two really important commands. Move, which is like what to do in the game at every move. And is game over, to tell me, like, should I keep playing? And finally, the run graphical game. This is the main class. This is where you're going to press the play button. If you notice, you can see over here there is a little play icon on that class. That one has a main method. It's the one that you're going to run. It controls everything else. It's the controller. It's going to go look at the model and say, like, hey, guess what? The user clicked here, model, make whatever move you need to do, and then go to the display class and say, okay, great, the user did this, so now my grid looks like this. Please display that grid the way that I want it to. So we're going to dive in deeper into the run graphical game class and the game board class, just to give us a little bit more insight as to what they do. And then we're going to have some time to experiment and explore so that you can see this working and running on your own computer. So the first thing that I want us to note is, like, what kind of class is this run graphical game class? Right away, I notice there's this import statement of processing. I see these words extends, papplet. I see methods like setting, setup, draw, and main. So I can conclude that this is a graphics class. Run graphical game is a graphics class. It uses processing to make a graphics window pop up when we run it. So this is a graphics class. When we look at that very top part, we will notice that there are two variables declared at the top of that code, like we declare variables int x. These two variables, their data types were the other classes. Notice the data type here is game board and display with a capital D. That means that those other classes that we are looking at are object classes. Specifically, we have one game board data type variable that is called game, and we have one display variable that's called lowercase d display. So you'll see those words game and display come up again later. Usually in my code they'll be highlighted in purple because they are variables. For you all on your paper, no colors, so you won't see that. But you will once you get to seeing the framework on your screen. This line of code here that I have circled, game equals new game board 5, 5. This is the line that's going to create the game board and actually say, like, hey, make a grid that's 5 by 5 to start. Notice it's calling things from the game board class, so now it's going to be using the object. In fact, this is the constructor to say, hey, let's create a game board that is 5 by 5. We're going to call it game here. But that's where we set the size of our game board and create the game board itself. We also have two lines still inside of that setup method, display.setColor. And those lines set a specific RGB color. Notice we've got the RGB color commands like we had from graphics forever ago. And they're setting it for a certain value in the grid. So for example, and in this specific case, a value of 1 in the grid is going to show up in red, and a value of 2 in the grid is going to show up as green. So that when we view those grids, we're not seeing the literal numbers. We're going to see a grid with a filled in square as either red or green. And you'll see what that looks like when you run that framework in a few minutes. There is another method to that Run Graphical Game class that we didn't have to have when we set up our graphics templates and our graphics frameworks. That is that mouse released method. Remember, that's a method that it has some built-ins, so it will run automatically anytime the user clicks. That's what mouse released, like as a method does. Specifically, this method has some things about location and then creating a row and a column. So location, this is also another object. That's a helper class. Its job is to save a specific row and column value. So it's a variable itself. Remember, it's an object, and it has two parts, a row and a column. You can tell that it's got methods that say get row and get call like that, so it knows to keep track of information of two different numbers, the row value and the column value. Then we get to use displays grid location at method to help us turn the mouse's position, mouse X, mouse Y, into a specific row and column. Because if you remember on our graphics window, the mouse is going to be somewhere between 0 and 600 if we have our window set to 600 by 600. But if we think about our grid, we aren't going to have tiny little grid that's then 600 by 600. We're going to have a grid that in this case is 5 by 5 and a really big grid that fills that screen. So where my mouse is in graphics position, it might be like, let's just say for example, my mouse in graphics position might be at 100, 300, but that might correlate to, oh, well that must be in, let's figure out what I'm doing here. Oh gosh, everything gets really weird. That might correlate to a specific row being 300, let's say that's like the second row, and 100 in the X direction, that's probably like the first column. So it would be in like row 2, column 1, even though it's at position 100, 300. It also gets weird too because like X values go to columns and Y values go to rows. So it's all kinds of backwards. So we're going to use location to figure that out for us, and we're not going to worry about it all that much. We're just going to know that location does all that calculation for us. Then we call game, our game object, we're going to call our game's move method, and we give it the information of, hey, the user clicked at this specific row and column. So that way game knows, oh, the user clicked here. So then let's dive into the game board class. Let's figure out what that means on the game board side of things. So game board here, public class game board, then has a method public game board. Notice that those match, class name and method name match exactly, identically. This method only has public and then game board, nothing else, no voids, no statics. That's because this is our constructor. And our game board class is an object. It's the template for a game. So in theory, we could have many games. Inside that constructor, there's two really important lines of code here. The first one is the line that literally creates the two-dimensional array. This is the part where we say, hey, Java, IntelliJ, computer, I want a grid that's going to be a new two-dimensional integer array of dimensions, height, and width. Now the size that we're passing in here is told to us from Run Graphical Game, that line that said game equals new game board 5, 5. Those are the 5 and 5 that we're passing in as the width and the height. to then create that 2D, right? And then the other line of code that's here sets the value of the grid. So that grid 0, 0 will be equal to 1. So here the top left corner of your grid is going to have a value of 1, and the rest of the grid will be filled in with zeros. Now, because of the way we dealt with the colors back in the run graphical game, where we had that display.setColor, the value of 1 is then going to appear as a red square when we run this game. So when you get your framework and you run it for the first time, you will see a red square in that top left corner, and that's why. Now, when someone clicks, the run graphical game code calls the game board's move method, which right now, this move method doesn't do much. We read through, it's got a system.out.println, then there's some place where we're going to complete the rest of the code, and then it says return true. So literally, all it will do right now is it's going to print out the debugging info message. It's going to tell you specifically where the user clicked. So it prints out that you tried to click in row blank and column blank, and then it just returns true. Now, logically, in the end, we want it to return true if the person made a valid move and return false if the person made an invalid move, and we will talk more about that returning aspect of things later on. There's also 3 other methods. So as we add more to move, we're also going to maybe add things to the other methods or use these other methods. So inside of the game board, there are these 3 other methods: is game over, get grid, and is in grid. So is game over is going to hold all the logic to tell you whether or not the game is over or should still be going on. So this is to make sure that we don't continue playing the game, after the game is won. We have this small little method called getGrid. Its job is to return the grid so that way you could give the information of the grid to other classes. For example, you could then tell display, hey, here's the grid that I want you to display. Or, hey, controller, guess what? This is the display that we are looking at. Or, sorry, hey, controller, this is the grid that we are looking at. And finally, last method is in grid. This is going to be a method of logic to avoid any kind of out of bounds errors. So this method will check to make sure that the actions we're trying to do exist within the grid. For example, if you have a grid that is 5 by 5, you can't access row 5 or column 5. It will give you that out of bounds error, index out of bounds error. So in order to avoid that, we want to be able to check to make sure that we're not trying to perform actions in row 5, column 5, because that does not exist. All right, so that's all of the things that are there. I imagine that as we were going, you were pausing that video to make sure you fill in all of the notes on your paper. If not, go back, pause where you need to, fill in where you need to, make sure that you are getting all of these notes down on your paper, and then use your notes to try to do some exploration on these exercises. Starting next week, we are going to use this framework and actually build a game. So it is so crucial that you understand what's going on in this framework. So please ask Jay and Tommy questions as you're working today. Make sure that we're making sense of this framework. Send me emails if you have more questions, and we'll see how it goes.